Okay, hold on. I wasn't prepared for all that. I was looking for her to
You
do
missed the
stuff.
camera, don't worry about it.
No!
Oh, you're more photogenic than most
I
people. Don't
hate
worry about it.
the camera. Hi! All right, well, this is some serious stuff here. I have cameras in front of my face. Hello, everybody out there. All right, so I'm going to go ahead and get started here. I just have a couple of things I want to situate the discussion with, and we want to give Leona ample time here to get into the meat and the bulk of the presentation. And you guys got to excuse me, allergies are killing me, so my voice is very raspy right now. Well, I think very exciting developments have totally shaped the transformation of where we are in history, where we are in the solar system right now, and why people should be totally excited about the potential of mankind. And that's what you're going to get from this presentation that Leon is going to give today. Let me just say that last night, Mr. Lyndon LaRouche, along with associates, participated in a presentation that they gave for a national webcast, which really set the tone for, as Mr. LaRouche says, the direction of our organization and how, one, we're going to break the population out of what he called the unnecessary fears that they're allowing to grip them every single day. And it was really powerful that what Mr. LaRouche presented last night in the webcast was a real channeling of the spark and the spirit of President Franklin Roosevelt. As Franklin Roosevelt in his first inaugural address said, there is nothing to fear except fear itself, nameless, unreasoning, unjustified terror that conquers needed efforts. Oh shoot! Now I just forgot. I was all excited. I had it memorized. Anyway, unjustified terror which paralyzes needed efforts to convert retreat into advance. That's the most important thing right now. Is that you look at the world around us and people are seeing the insanity of a Congress that's acting like a bunch of cowards that will not impeach this president with all of the crimes that he's committing. From, right now, we have just as of yesterday morning committed airstrikes in Isbil in Iraq, and are sending troops into Iraq without the express consent of Congress. You have a total blowout of the financial system. NATO is now being commanded by Cameron in Britain, Prime Minister of Britain, to send troops and forces onto the border of Russia. Russia is preparing itself as we speak right now for the threat of warfare. And Russia is already sending troops onto the border of Ukraine. And now you have a situation where, as the tensions continue to escalate, you can look back at 2 weeks ago when this Congress finally got together in defense of the Constitution around the passage of H.R. 105 and said that the Congress upheld the Constitution, stating that the Congress only has the authority to declare war, not the president, and close to a unanimous vote of over 340 representatives voting together, both Democrats and Republicans, to put this president in his place. Now, they didn't finish the job. That's the problem. And what we have been unleashing is a whirlwind in the population. The population has to declare that Congress gets their behinds back to Washington, D.C., that they finish the job immediately, And that means that this president has to be impeached. And I think that it is absolutely critical that people understand, as Mr. LaRouche said, the universe and the solar system in which we're functioning in declares our ability to be able to crush this enemy, because the enemy is not real. Obama is just a joke. He doesn't represent anything which is real. Therefore, why is this Congress afraid to go after him? Why do they actually have a fear of somebody who can't carry out anything? It's just a total bluff. You know, Obama, as Mr. LaRouche says, has no capability whatsoever in carrying out this war threat at all, no capability of defeating the Russians or anything that he thinks he may be able to do. And when it came to actually addressing Obama's influx into Iraq and the whole situation in Iraq right now, he stated this. LaRouche just made the point that, hold on one second, I want to read this line. It was funny. I just lost it. Sorry about that. Anyway,
one thing you said.
Go ahead.
You said Obama's an asshole.
Yeah. Well, that's a simple. Yeah, that's what he said. Basically, he said Obama's an asshole, and this jerk is not going to succeed. We know what the Russians are doing, as I said before, that the Russians are preparing themselves not only for military warfare, but for financial warfare. And you think about the fact that, you know, as Cameron is saying that the Prime Minister in Britain has declared that we have to escalate against Russia. You have the insanity coming out against Putin right now, coming from the United States, coming from Britain and other factions within Europe, where this guy Munchau in Germany has now declared that, you know, we have to immediately finish off and go after Putin. And then you have a situation where the continued escalation is, what is all this for? What is the intention? The intention is because you have a bunch of cowards who do not want to actually address the reality that this British Empire is finished. Its whole financial system is finished. You know, the Russians know that. That's why when you have people like the talking head for the British Queen and the Empire, Ambrose Evans Pritchard, who is the writer for the Guardian. Was it the Guardian? Yeah. Ambrose Evans Pritchard is saying, you know, that Russia has, you know, basically provoking war with Russia, saying Russia has close to only 72 hours as of yesterday to either respond or face the wrath of war. Basically, that Putin, if he doesn't respond to the attacks on the Russians on the border of Ukraine, Russian activists, then therefore there is going to be war. Now, look at the insanity of this when you see the fact that you have a situation where this whole transatlantic system crumbling down now, the entire financial system in a free fall, and they want to play games, and it's backfiring on them. That's the wild part about it, is that, you know, they're trying to actually put Russia into a corner when they're actually putting themselves into a corner. I'll give you an example. You look at the situation where they're saying if Russia goes with the collaboration of the BRICS nations, Russia, India, China, Brazil, South Africa, that this is going to harm them economically and financially. Well, we're finding out that it's actually harming the people who are putting the sanctions on Russia more than it is Russia. So when you have the Eastern nations, or the nations of the European Union, rather, that is getting completely slaughtered themselves by these sanctions, that's a big problem. You have, for instance, just an example, in the United States, or rather, I'll start with in Italy. Italy is the largest exporter of wine and so forth, and they export this to Russia. Because of the Russian sanctions, they've been told you can't export this wine to Russia. Poland, the largest exporter of apples to Russia. So many apples, Poland's not going to be able to eat all the apples on their own. Russia can't have it. Russia can't have the wine. So these nations are losing ground, they're losing income, they can't actually have the resources to feed their population, and the Russians are having to go to South America for their cooperation. For instance, going to Brazil, which is going to produce hundreds of uh, tons of poultry, of chicken, of other resources that the Russians need. You know, they don't have to come to the United States because Brazilians can produce much more. So that's just an example of how insane we can become when we actually accept these lies, the lies that are getting us into this insane war right now, the lies that you can't impeach Obama because it's never going to pass through the Senate, or you can't impeach Obama because the Democrats are going to make money off of impeaching Obama. I mean, that's the most insane thing. Well, first of all, we should tell people who say that impeachment isn't going to be passed to the Senate. First of all, look at the history. Remember that 40 years ago today, Nixon was demanded to resign from the presidency by members of his own party who went to him and forced him out of the White House. So, and it didn't have to go through a senatorial process or a conviction of that nature in the Senate. So we can go, and especially Democrats, they know what's best for them, who do their job and get over there and say, Mr. President, you done lost your damn mind. Get out of here. So, you know, because the Democrats, they recognize that something was, the power, usurping of power had to be stopped when Barbara Lee from California went with Rangel of Florida, not Rangel, Regal of Florida, and they put their statement together, stopping the usurpation of the president over the executive, the checks and balances of the Congress. You had this with the passing of H.R. 105. So I would just say this, look, we have to escalate. People have to get out there and not be thrown off. Not be thrown off by their own fears, not be thrown off by what is, you know, they think is practical, or what these Congress members or what the population is going to be respond to. We have to go for absolute truth. And you have that truth is defined very powerfully and very beautifully in what Mr. LaRouche said yesterday, is that people don't understand the galaxy or the solar system which they live in. We can solve all of these problems. War is a unnecessary action. Unnecessary action. The fear that people are living in right now, the turning, the retreat that people are in the midst of. You know, we're talking to people every single day that are allowing for the BS talking heads on the Rush Limbaugh and everything else, and the cowardice of Congress to determine and to dictate what their futures are going to be. And that's why I'm going to say that everyone watching, listening in the room with me should really go and study the presentation that was given by Mr. LaRouche and members of our organization on yesterday, on last night, and get a sense of reclaiming your true American identity, creative potential, and potential as a human being in the solar system, totally capable of transforming the conditions of mankind on this planet and beyond. And let me just, on that, I want to read just two quick things here to situate, and then I want to turn it over because I want, as I said, I want this to be quick, and I'll answer any questions later on the political situation. But let me just take very quickly from a passage from the presentation that was done last night, in particular Mr. LaRouche's remarks, and give to people. Now, as the situation was presented by, in which I presented today thus far, in terms of the threat that we face. First of all, Mr. LaRouche says the biggest threat to our national security is Obama in the White House. So we know that's the biggest threat. We can solve it. Second biggest threat is our acceptance of this and our fear. And after looking at the conditions facing and gripping mankind, Mr. LaRouche says, now, how do you understand all of this? First of all, first, the first thing is you've got to know where you're living. You're living in the solar system. The solar system of relevance is what? It's the moon. It's the moon. The power is that of the moon. The economic power of the planet Earth is of the moon. So what are you worried about? Yes, there are tactical questions you have to consider, but when you get worried that is this crap that you've been dosed with is somehow reality that you have to fear. It's the fear that destroys you because you believe in that fear. What's the basis of the existence of mankind as a human species within the solar system? What's the basis for the existence of the moon? The existence of the moon is the existence of the moon. What is the importance of the moon? Well, the moon is the source of all its importance. So he goes on to say, so this piece of idiocy, of this belief that this kind of thing that Obama's doing, the British are doing, the insanity that's going on, in emphasis here, it only works if you're stupid enough to believe in it, if you're dumb enough to be taken by it. And that's going to be the essence of our discussion here today and what Leona is going to present to you. How do we overcome these fears? How do we look at the power of the creativity of the human mind and what particularly nations such as Russia are doing right now to lead the world, to lead the planet and mankind to greater endeavors which actually increase man's power over the universe, that increase our power in a productive, not destructive way, because Obama's out to destroy, the British Empire is out to destroy, while you look at what the Chinese, the BRICS, the Russians are doing, they're going for full unleashing of the truly creative powers of man, which Mr. LaRouche recently said that creativity is creativity for others, creativity for the advancement of others. And that's the idea. Creativity is not something that just exists in a box or, in your basement somewhere, or, when you feel like it. It is always advancing the creativity of others around you. So I want to leave it at that, because I think that with everything that's going on, we can go through the details of the political situation, but in essence, it all doesn't matter, because what matters is whether or not we're going to overcome these fears, tackle this enemy, and actually move forward with the processes which declare a real commitment toward true human progress. So with that, I'll leave it there, and Leona can take it away.
I'm going to turn off our thing here. So. Just a minute while the projector turns on.
Okay.
Okay, go ahead. I'm going to mute us, and then we can unmute it later for questions.
Okay, can you hear me?
Yes.
Okay. Okay, I think that's a pretty good setup. And what I want to talk about today is particularly two things that Mr. LaRouche brought up yesterday, which you'll see bring up everything else. And Keisha already introduced it, which is what makes us unwavering in destroying the problems of today. And that aspect, the answer to that is a capability to understand the nature of human beings. I think this is, it's something that is never discussed or debated in Congress, and yet it's the foundation of all laws, of all things that are being instituted for all mankind, or even for a nation or a city. The foundation actually is what's the destiny of society, and what's the nature of how society functions, how a human being functions, how a human mind functions. And so that concept, the understanding of specifically the creative capability of human beings has almost completely been lost from discussion in society, and definitely in education in society. And that has led to one, demoralization, but two, an inability to visualize, to have a vision, to have a sense of where society should be right now. I think that really is the one of the two things that holds people back from just saying, I'm not going to put up with this. And I think sometimes, talking to people, and I think, why do I need to convince you that you shouldn't put up with this? But we do need to convince people that, because people are putting up with all this mess. The other thing which I think holds people back is the understanding of really what we're dealing with. in a sense of what is the enemy here. And I think to get at that question, it's easier to start with the first, which is what the nature of mankind is. Now, Mr. LaRouche has put together a set of 4 laws, and in the midst of this crisis, he said, okay, do this now, and this will solve your problems. And that's pretty bold. It's only 4 laws. It's not a whole... anyway, it's very bold, but you'll get a sense after studying them of why it's true that these 4 laws will bring us to a new renaissance. And so, for people who don't know, haven't read it, 4 laws, Glass-Steagall, so after, in the process of impeaching Obama, Glass-Steagall put together a credit system that is going to fund based on the future, having a plan of what to build to increase the productive power of society, and then 3, a science driver. And this is very important because a lot of times people think of making policy based on, okay, 1, 2, 3. We know we have to, it's sort of a schooling system, right? Elementary and then junior high, and then we know they have to go through calculus 1, 2, 3, and so on. It's not really how economies work. It's not even really how education should work, because it's not how the mind works. The way that economies have worked, and if you look at historical examples, like during the Apollo program or during the recovery out of the Depression, Roosevelt era, they were always guided, organized by a driver program, a science driver program, and specifically something that is going to challenge the very foundations of what human beings think they are. And right now, Mr. LaRouche has defined that as 2 things. 1, fusion, a major drive to control thermonuclear fusion. And then 2, the development of the moon. So I want to go through that today. We'll start with fusion. So this is the usual understanding of what fusion is. It's a reaction that happens between 2 light elements, usually 2 forms of hydrogen. Tritium, in this case, which is the one on the bottom, and deuterium. And it can happen amongst several different combinations. This is the one most people are working on. Okay. Now, it is very interesting because you're fusing 2 atoms and creating an immense amount of energy. So this is just a good comparison of what that means. So hydrogen is very light, and so per amount of hydrogen, per amount of these 2 types of hydrogen, or helium, which is what we're going to get into in a second, or a few minutes, you get a lot more energy out. And for people who have seen coal trains or trucks carrying petroleum, you get a sense of just how much volume is used in powering the United States or elsewhere, depending on where you are. And you'll see that now this is a chart. If you look at the table to the top left, you'll see that if you compare wood, coal, petroleum, each of them per weight. So petroleum puts out more energy per weight than wood, for example. Right, 3 times more than 3 times more. Now, though, if you once you get into the nuclear domain, though, let's get to uranium, for example. So fission power. Why do we want to build nuclear plants? Fission power. Per pound, uranium produces 10 million kilowatt hours. So this is a million times. Fusion puts out then 4 times that. So you're dealing with orders of magnitude. You're not dealing with just a little bit more, like for example with natural gas. You're dealing with millions. So that is, I think, that's the general conception of fusion that people who have looked at fusion might get. What I want to get you is a sense of what it means to have a fusion driver, to invest in something that doesn't seem to be, it doesn't really seem to be directly addressing all of our very crucial problems, the water crisis, the war, unemployment, and so on. Why would you choose this as a major project to invest in when we have all these very large problems? I'm going to say right now, this will address all of those, and directly addressing any of those will not work. So we'll come back to that. So the sense I want you to get of what fusion actually is this. I'm going to go through a few different types of fusion reactors just to show you what we're dealing with. So this is a type of fusion reactor. This is an image of this thing is, the capsule you're looking at is about an eraser size. And we're dealing with 192 lasers shooting at this eraser-sized thing. And it's creating temperatures that are hotter than the sun. Now, in a few other, so how hot is the sun? The sun is about 1 to 27 million degrees. That's very hot. I know people don't have a sense of what that means. The highest melting points for any type of material that we use, any metals or ceramics, is about 3,000 degrees. And so maybe that gives you a sense. It's very hot, so you get a sense. The sun is about the hottest thing most people can think of. When we're dealing with fusion, you deal with temperatures that are about 100 million degrees. A couple of reactors produce temperatures that are more like 1.2 billion degrees. So much hotter than the sun. This particular device, which is in California, at Lawrence Livermore, also produces densities that are about 10 times, about 6 to 7 times more than the sun as well. So this is 1,000 times more than, and basically the densest thing we know. With a different type of reactor, or one of these lasers, that's not particularly this one, but one they made for this purpose originally, can make a light that's brighter than any star we know. These are just a couple of different reactors I'll show you. There's several ways to create fusion. I'll get back to these actually. So, okay. So the reason I want to point this out to you is because this is something, first of all, that has already happened. So this is not part of the driver process. I just want to show you what we're dealing with. You are dealing with an era now where human beings have come to the point where they have become more powerful than our sun. than our solar system, than what guides the solar system. And when we're doing it right, always human beings are continually increasing that power. And as Keisha said, that's real power. Right? It's not a power to destroy something. You could, if that's what you wanted to do, but it's really a power to do things you could never do before. And now what can we do with all this? Great, this happens in a lab and so on, but so what? Okay, well, I already mentioned the producing lots and lots of electricity, lots of power, lots of energy, that is. But it's much, much more than energy. The one thing that, one of the things that might be easier to understand for people who have really never dealt with fusion or a nuclear process is right now the society as a whole has a very good understanding of chemistry. We can make polymers, we can make all sorts of different materials. You can make materials that have a fine finish of some completely other properties, and so on. We're very, very good right now at dealing with the chemical domain. Now, that capability, that precision, can be had in the nuclear domain. Now, what are you doing with, what is nuclear? Nuclear is elements transforming into other elements. Right, so this is you can turn mercury into gold if you like. But a completely different ability to control nature, to deal with nature, to be part of what is occurring in a natural process. Fusion, for example, up to the point where we were able to create fusion in a controlled way in the lab, or in bombs prior to that, happened on the sun. That's the only place we ever knew that it happened, on the sun or on other suns. And only with human beings, with scientific thought, have we brought that now to the point where we can create it willfully, and we could bring it anywhere we want. And really, with this type of power, another thing is true, which is, let's say, for example, we start to desalinate on a mass scale. And Ben went through some of this yesterday. If you wanted to desalinate water to replenish the Colorado River Basin, which is about 7.3 cubic kilometers, is being lost every year. If you wanted to produce that amount of water by desalination, you could do it with a third of a ton of fusion fuel, a particular type of fusion fuel, and we'll get to that in a second. Compared to 66.7 million tons of coal. So you can desalinate with coal, and that's the desalination plants now do. But it's a lot of coal. It's a lot of infrastructure. It's a lot of activity. And anyway, we don't do that right now. If we were to start desalinating on a large scale, on a massive scale such that you're desalinating basically rivers full, we would start to create sorry. We would actually start to really act on the scale that the global water system is acting on. Now, currently in nature, desalination occurs through the action of the sun. So it's constantly evaporating water off of the ocean and off of the land, bringing it up as desalinated water, and it's then coming down as rain. Mass desalination would put human beings, again, on that level, controlling something that used to be only done by the sun. So I hope that gives you a little bit more of an understanding. Another thing that that will be fundamental is fusion is also, when we deal with fusion, because we deal with these extreme temperatures, these extreme densities, and so on, we also start to deal with a form of matter which completely challenges our basic understanding of physics, how the universe works, and so on. And we come to realize that it's much more ordered than we thought. It's much more, it's much less chaotic than we thought. And I think the whole chaos universe, the universe is going to die eventually and wind down to nothing, that's a political operation. I mean, it just doesn't work. And I'm glad that we had to make a discovery to prove that it doesn't work. It never worked, though. But that type of idea posed into physics that, there's a lot of things are statistical, it's really not understandable, it acts in a lot of different ways, especially into the way that people think other people function. And therefore, it has an influence into policy. I don't want to get into that. That actually is maybe in the question and answer. I can give you a very good example of that. What I want to get into is helium-3, because if you listen to Mr. LaRouche's webcast last night and the past several things that he's done, that is the most common word that is repeated, helium-3. I guess it's 2 words. But now Mr. LaRouche right now is saying helium-3 is the driver. Helium-3 fusion, particularly. So what does that mean? Let me go back to this diagram that we had before. Okay, so actually, can we do this? Yes. Okay, so this is a chart. I'll decode it for you. Helium-3 it's helium. Chemically, it's helium. It will do all the same things as float and so on. But in the chemical domain, we wouldn't care if you have one form of helium or another, and you wouldn't be able to tell. In the fusion domain, in the nuclear domain, it makes all of the difference. So the one I showed you earlier, the fusion reaction I showed you earlier between deuterium and tritium, so it's 2 different types of hydrogen, produce a helium, the most common form, and a neutron. The one that, and if you look at these MEVs, those are measures of energy. So you see, the first one produces 17.6 MeV. Mega electron volts is what they're called. The next one produces less. You see a total 4.03 MeV. The next one, which is deuterium and helium-3, is a form of a much rarer form of helium on Earth, at least. Produces more. Right, you'll see a total of 18.3 MeV. And then there are other ones. Helium-3 reacted with helium-3. And then another form of fusion which people are working on is boron and a proton, which is basically a form of hydrogen as well. Now, if you notice, there's two things here. The highest forms of fusion are the first one. Highest forms of the highest amount of output of any fusion reaction are these two: the top one and the D-helium-3, the deuterium and the helium-3. And so let's look at those two a little bit closer. The one that's the top row is the one that I said most people are working on. It's considered easier to make happen, and people have made fusion with this fuel. They haven't made fusion to the point where the fusion energy compensates for the amount of energy you put in, which then, of course, is not very useful for energy production. It's useful for other things, which, for people who had a chance to read the paper that I published, you'll see a few pages on that. But for energy production, it's not very useful because of particularly where the energy goes. And you'll see it says out of this reaction, deuterium and tritium, you get hydrogen or helium and a neutron. That's what the N stands for, neutron. Most of the energy comes in the neutron. Now, neutrons are they're sort of pesky. They're hard to control. They're not charged. Magnetic fields don't affect them. And so what we do with neutrons now, for example, in a fission reactor, is we send them through water. The water slows them down. It creates a lot of heat. The water boils, creates steam, and then the steam can be run through a turbine. Now I want to show you a picture. Let's see. Okay, so this is a fission reactor. So it's basically going through the process I just described. The fission fuel undergoes fission. That heat then is being transferred. Oh, the fission is then releasing neutrons that is then being transferred into the water, and the yellow part is just very hot water. That then is then run through other water, and which boils it. So this is a fission reactor. This is a coal reactor. So if you look at it, coal is being inputted, it's creating a lot of heat. That heat is being transferred to water. Water is being transformed into steam. Steam is going into a turbine, and a turbine is generating electricity. It even has that tower that people think is unique to fission reactors. That tower is putting out steam, by the way. Okay, so I just wanted to show you that because if we were to use fission in the way that we use fusion now or coal now, that's not really a big shift. It is in the sense of, yes, it's a lot more energy per weight, but you're doing the same thing. And the problem with doing the same thing is it's also 60% inefficient. So, in other words, 30 to 40% of this whole process, of all the heat that comes out, is actually transferred into electricity. The rest of it is waste. It's considered waste heat, is what they call it. Now I'm going to go back. Let's see if we can organize this. Okay. Now, if you go look at the next one, the other one we were looking at, deuterium and helium-3, you'll see it also produces a hydrogen, or a helium, the most common type of helium. But the second particle it puts out is a proton. Now, what's useful about that? The proton is charged, and for those who don't know, when I showed this, let's see, this picture, this is a picture of a fusion reactor. So inside of a fusion reactor is what's called plasma, charged particles. The charged particles are whirling around 100 million degrees or a little less, and it's all being confined. It can't, of course, touch the walls because remember I said that metal melts. All metal that we know melts beyond 3,000 degrees. So this is 100 million degrees. It's being confined by a magnetic field. And the great thing about this is that it, because we are able to use this invisible field, we can control these type of, we can create a completely new environments and new states of matter. Now, the other thing is that, you know, Ben mentioned yesterday in Mr. LaRouche's webcast that there's 20th century energy production and then there's 21st century energy production. 21st century energy production is, I would say, is when you get out of having to use a chemical process to do anything. And here's an example. Unless it's facilitating a nuclear process. So what do I mean? Helium-3 is, or I'm sorry, the proton that comes out of this fusion reaction is, sorry, I have tons of other pictures, and we can go through them maybe afterwards. This proton comes out more energy than the neutron previously. It's most of the energy, and it comes out in a way that's charged. It can be accessed by a magnetic field. You can use a magnetic field to funnel it, for example, out of a rocket. But you can create a stream of these protons. And what is a stream of charged particles? It's actually electricity. Electricity is a stream of electrons. So already you have electricity, and there's several different ways to, to make it the most efficient. But in theory, you already have electricity. It's already there. It's just a matter of making it conveniently converted, basically. And so what this gives is an incredible amount of conversion efficiency. Some, depending on your apparatus, 75–80% of conversion efficiency. But so that's energy-wise. It also gives you something else, which is it gives you a capability to, like I said, direct these particles with a magnetic field. Again, I said the particles cannot touch any metal, but you can direct it with a magnetic field. You can direct it out of a fusion rocket. So what does that mean? Now, what does a fusion rocket do for us? What's shown in here right now is Earth's orbit and Mars's orbit, or just some other planet, the one that we're trying to get to. So right now, let's say we wanted to go to Mars. This circle right here in green, labeled number 2, takes about 8 months. So you don't just go straight. As if I pose this to an elementary student, they probably just draw a straight line. You don't go straight. You have to go through this loop. And it's basically an orbit that anything else would take. So here's another example, yet another example where we have surpassed the power of the sun. So normally our travel in space operates by, we have to go in orbits. That's just the shape of the solar system. The easiest thing is to go by orbits. And a good way to understand it is when you're hiking up a hill. There's ways you can go, if you ever, when you're hiking, go get one of those, what are those called? Those maps that map out the altitude, the height. If you travel along one of those lines, so if you travel at a constant height, then you may be walking for a long time, but you use less energy. If you go up, then it's much harder. Well, these orbits are sort of that. They're the what's considered flat to you at that point. Now, when we start to deal with fusion rockets, well, let's say this. The way that we travel now is we basically turn off our engines. We get up there and we turn off our engines and you sort of just coast. And the reason we do that is because the type of fuel we use now doesn't allow us to do any more than that. It's very heavy. The fuel weighs more than the rest of it, the part that you're trying to carry up. And so that's pretty much all we can do. Once you start to put up fusion rockets with this type of fuel, for example, you can constantly accelerate. That means you can go straight if you want to, what we think of as straight. You can basically jump from orbit to orbit. So this would be actually like going straight up the hill. Okay. Okay. So I hope I haven't lost anybody. If I have, just complain in a few minutes when we have question and answer. So why do I go through all this? It's helium-3. That's where we are right now. Why is Mr. LaRouche hounding on? We need helium-3. China's getting it. China knows where we should go, and we need to collaborate with them. That's what he's declared is really the strategic outlook right now. Okay. Well, a good thing, the advantage and the disadvantage of this great fuel, helium-3, is that there's not a lot of it on Earth. There is some in old nuclear warheads, which is enough to do research with. There's not a lot of helium-3 on Earth, and largely because the biggest source is actually from the biggest source of the biggest fusion reactor we know, which is the sun. The sun outputs helium-3, but our magnetic field, the Earth's magnetic field, blocks it. So it just bounces off. The closest place that we can get helium-3 is the moon. So, though some people may think of this as a disadvantage, Mr. LaRouche thinks that this is great. This is an advantage. Because to get this greatest fuel that we know of yet, we have to go and develop the moon. And so it sort of becomes a pathway to do something that we needed to do. We have to do anyway. Because what's the moon? The moon by itself is not anything in particular, especially right now. As a big dust ball, it's not really anything at all. But one, when we're using it to mine helium-3, and two, when we're using it as a launching point to anywhere else in the solar system, then it becomes one of the most valuable things that we have. It becomes a sort of base, home base. And that's really it's something that it's a point where we should have been 40 years ago now. 30, 40 years ago. Right now it's considered the return to the moon. But even at that point, even in the 50s, leaders knew that the next step for humanity is we have to consider how we're going to control and be a steward for the solar system. How are we going to mine asteroids? How are we going to understand our own weather? How are we going to understand the sun, which is the same thing as understanding our weather, and so on. And so it serves two purposes. Well, it serves, besides the purpose of being used as a science driver, going and developing the moon for helium-3 will serve as a launching pad for development of humanity beyond this Earth-based thinking, this sort of small, bickering thinking that we have. But the other thing is that in this process, we can use the process as a major education of our population about what we are. So it's a bit of a catch. Okay, you have to educate the population about what we are to get people to be unwavering about what we're actually fighting for. But the other aspect is the whole process of development is going to bring a whole other generation where that's just the truth. Human beings are creative. We are much more powerful than the sun. We're probably going to leave the sun probably in 1 billion years. And that's just what we are, and that's our responsibility. So it also serves as a form of educating this generation, this whole population, which is, I have to say, it's not doing so well on the IQ scale. So I just want to bring it back now to some of what Keisha was saying at the beginning. Now, why is this? You know, there are all these incredible dangers. The biggest one, of course, is thermonuclear war. War with Russia or China or both. And you know, with the historical, you know, people call it the war. They didn't call it World War until it became World War. And they didn't call it the First World War until a Second World War occurred. So these things are uncontrollable, like a nuclear bomb. But the other aspect is that the war right now is being driven by rules of the game. And you see it with that's what Keisha was going through, was that there's all this incredibly insane media going through the war drums. Right? This is what we have to do. Can you do something else other than this? And it's all fake. And in reality, like I said, the power of human beings, real power, is in what I just discussed. And China, Argentina, Russia, especially China, actually, understands this to some extent. Maybe not to the extent that LaRouche has really developed it, but definitely to a very useful, large extent. And China, since 2007, really since 2004, but especially since 2007, when the whole crash occurred, has really just refused to go along with this whole bailout, bail-in. They refused to follow the rules. And instead they said, we're just going to build. We're going to graduate 2,000 fusion engineers. We're going to build hundreds of miles of rail, of magnetic levitation trains, which people say are just too expensive. We're just going to build it. We have a space program. We're going to the moon. I know people said we've been there before, but we haven't been there before, so we're going there, and have really decided to say, okay, we're just going to build real wealth. And they come out of this point where, people always say made in China, oh, that's just an imitation thing. Fusion engineers that have come back from China have told me that that's just a lie. At this point, they're completely out of that. That's not even true. And China is now producing technologies and science that is above and beyond. And it's unique. The reason I point this out is these type of things are the nature of the U.S. This type of thinking is the nature of the U.S. It's how the United States was created, and we do have an incredible potential to take this outlook and create an international effort to develop mankind way beyond where most people have ever even dreamed. This is already the direction of China, where Russia would like to go, India, and so on. And so it's not just something that we're starting, although we did start it. But it's already a direction we can go in, and we have to. And I think it's really important to, Mr. LaRouche pointed out a couple of times. Here's how it started. Somebody asked him, okay, what are we doing about this? How is this helium-3 stuff going to address the fact that there's this war going on and they're not going to let China do this? And his response was just superseded. And at first you're thinking, what do you mean just superseded? But it is really true that more than half of what is feeding this whole process is a complacency to follow these rules, to say, oh, okay, yes, humanitarian, yes, that's what must be. I mean, no, but most people don't believe this crap, but people follow the rules. But we've seen, especially recently, for example, with Argentina, where they just didn't follow the rules. They were put in a condition where they were going to go bankrupt either way. The two decisions they were given were going to make them go bankrupt. And so they chose neither, in a sense. They did not follow the rules. The world backed them up, and they're still around. They have a sense that they're building a new system, that the old system is dead. And that's really what we have. Like I said, this is a really good. Let's say this. I said earlier that there's two things that really hold people back, I think. One is a sense of where we should be, and then two, a sense of who we're dealing with. So where we should be, I think, I've only given you a very small picture of it, but hopefully you have something, though, which is bigger than most people think. But two, what we're dealing with. And the enemy right now is the anti of what we just described as the nature of humanity. Right? It's the sort of the Zeus principle, the attempt to crush that exact nature of humanity. For example, the developments that are happening in China or in Russia or in the United States. If you look back, that is, and some of the people in the room in there can take you through these examples where the exact thing that's being attacked is this. It's not power, it's not money, it's not greed, it's exactly this. It's the creative capability of mankind. And anyway, we can go into that, I think, in discussion. But I just want to reiterate that point that, you know, this, a lot of the things that we bicker over, that Congress bickers over, is within this, it's within this box. It's within this box that's been created. Oh, well, we have to work within the confines of the current financial system and so on. But what Argentina basically declared, what China has been working on, is that this whole financial system, it has no power. It's dead. And we have to understand that. The United States has to understand that. And we have to hold that as a torch and saying, this whole fraud is dead. And we're much bigger than that. That's what we're fighting for. I think people have to take it as a personal responsibility to continue to build this picture of what it really means for you to be a creative person that has the capability to control the sun and any other and much bigger things as we progress, and that this is real power. I'm going to stop there. There's a lot of things I'd like to go through, but I want to see if anybody has some things boiling in their mind. Some questions, comments.
What I'm going to do so that there isn't this double thing, maybe I can turn the camera this way or something. If you want to ask a question, you can just come up here and talk to Leona. Is anyone on the phone team here have a question before you want to go back and do your work?
For people who are watching on YouTube, if you post a comment to YouTube, I'll be able to see it.
And,
Hi, Leona.
Hi.
Hi. One of the questions that came up in our discussion the other day here is, I mean, there's never actually been, correct me if there has, an actual reactor that has used helium-3 for fuel. So how do we actually know? I know Lynn's adamant about it, but how do we actually know this is the most efficient fuel for fusion energy?
Okay. Yeah, you're right. Well, all of the fusion reactions have been performed before, but all on small scale. You can do it, one atom at a time, basically. They've done it with lasers. They can do it with, basically, you can do it on a laboratory scale. And that's how they know, for example, how much energy goes into each part. But the question is, can you get it to ignite, so-called? Can you get it to have so much fusion, so that there's a density of fusion reactions such that the amount of energy from it feeds the fusion reaction itself, such that it's self-sustaining. It's powering itself, and that's what they call ignition. So once it's powering itself, then hopefully that it then is creating an excess amount of energy. So that's what people are working on right now. Theoretically, it puts out the most energy. I think besides the energy calculations, I think Lynn has something else in mind. And I do think it's actually, one, that yes, it is a lot of energy. Two, it's capable of direct conversion, which is direct conversion into electricity without a steam cycle. But three, it's this aspect of developing the moon. It's the fact that it's on the moon, and it's not only on the moon. It's on. You can get it from Jupiter, from anywhere basically that is exposed to the sun, and doesn't have a magnetic field that's repelling it. But I think as a driver, it's that aspect. So the fact that it's connected with the moon as a next step of development. Yes, it is harder to get, as far as it needs higher temperatures and higher densities and so on, but those things we can get. I mean, we've already produced temperatures that are capable of doing this, and they just need to have a couple of I think they produce the temperatures, they don't have the densities yet. But the other thing is that I'll point out that's more of a practical thing, which is that once you start to get into aneutronic fusion, so fusion that doesn't have neutrons, you actually simplify things a lot. And I'll give you a good example, ITER. So ITER expects to use deuterium tritium fuel. It expects to create lots of neutrons. Most of the apparatus is to shield everything from neutrons. Now, ITER right now doesn't have any energy collecting capability. It doesn't have, a steam cycle attached to it or anything. It itself is huge, but most of that is neutron capturing capability. Because neutrons, when they shoot at things, they degrade things. They transform things into other elements, and usually it's into more brittle elements. So the other part of what's all in ITER is it's completely automatically controlled because of the neutrons. So they don't expect to actually put people in the environment because it's going to be highly radioactive. And so it's all automatically controlled. They've got robotic things and so on. Once you start to get into aneutronic fusion, that all is unnecessary. You can put people next to it. You don't need a neutron shield and so on. And so it's simplified. I don't know if Lynn is thinking about all this, but it's very pertinent as far as what type of reactors are possible. If you're going to put something on a spaceship, you don't want to be putting this huge magnets and huge walls to protect against neutrons and so on. So that's the other aspect, is aneutronic fusion. I don't know if that answers your question. But.
So we'll repeat the question for everybody else.
Hi, Leona, it's Evelyn.
Hi.
My question is the question of mining and bringing back helium-3 from the moon. I mean, we've reported on what the Chinese have for plans in terms of an orbiter and, then another rover mission and this sort of thing. Do we either know any more about what they're thinking, or have we done any work on what a crash program to carry that out? Say if the U.S. and China and Russia were to carry out a crash program to be able to get to the moon and mine the moon for helium-3, what that would look like?
Have we done a detailed study? No, that has not been done. That's sort of the next step. As far as mining the moon, that has been, I do a picture. I'll show you. There have been studies on how to mine the moon. Schmidt wrote a whole, so Harrison Schmidt wrote a whole thing on it. Where is this picture here? Wrote a whole book on it. There's a study group in Wisconsin, which specifically studies helium-3 and helium-3 fusion, and so on. This is just a picture from one of the papers by a man named Taylor, which you may or may not be familiar with. He was the first one who discovered that you could microwave lunar soil, and it would melt. It would heat up very quickly with very, very little amount of microwaves. So basically, he discovered a tuning of the soil there. But this is his apparatus of paving the roads, basically, with microwaves. And in this process, in this heating up process, volatiles, which are basically anything light, comes out. So helium-3, because it's deposited from the sun, is all on the surface. It's all very lightly dispersed on the surface. And so therefore, if you heat the surface up a little bit, you can detach the helium-3, or all things, helium, carbon, and so on, out. Or all the gases will come out. And so you collect them, you filter them, and so on. So that part, as far as like how to mine it, what type of things to use to mine it, and that stuff, that actually has all been studied. Obviously, all of it needs to be tested. And part of the funny thing about lunar soil is that it has such unique properties, it has never been replicated. And one of the things, for example, is this, the fact that you heat it up really hot, it doesn't really do too much because it's just, it's rocks. So basically it's silicon, iron, made out of the same things that rocks are made of here. But if you heat it up with just a little bit of microwaves, it melts. And so that's a unique property of the things on the moon. That all that stuff is going to have to be tested with more than just a couple of rocks that we brought back from the moon. This type of stuff, Taylor has worked with people in China. And Taylor's from Tennessee, I think, or Kentucky. I think it's from Tennessee. Anyway, and so it really is. It's not a technical matter. In other words, it's not something that we don't know technically. It's all an intention question. No, I would like to put it together something that has at least a rough sketch of what a crash program timeline would look like.
Thank you.
Okay.
Hi there. This is Ted Holden. I've brought a copy of the article on thorium, which people have been looking at. I'm going to give this to Keisha. Hopefully she can get it to you. Okay, you've got a Nobel laureate, this Carlo Rubio, who has basically said that thorium trumps all other fuels. There's no question about it. In other words, you've got a workable solution sitting here which doesn't require inventing anything that we don't already have. You could just start building. Nobody wanted to hear about thorium in the 1950s because you cannot make bombs out of it. That says, Hamas cannot make bombs out of it. Nobody can. It's hundreds of times more efficient at producing energy than uranium. This is much more common than uranium. It could hold the human race for all of its energy needs for 1,000 years or thereabouts starting from now. To my way of thinking, this has to be on the front burner. Fusion, I believe, needs to be on a back burner. It needs to be on some burner, right? But until you know of a way to do it, which is believable, it doesn't require inventing anything or wishful thinking of any sort, then I don't see how fusion could be on the front burner. Okay, let me run something else by you. If there is going to be such a thing as a believable version of fusion being used to produce energy, then that has to be within certain parameters. It has to involve reasonable amounts of time, reasonable amounts of money. Whenever you hear somebody talking about needing decades or quadrillions or quintillions of dollars, then nothing good is ever going to come of anything like that. Okay, that guy is a con man. He's a BS artist. You really should just tune him out at that point. One of the jobs that I've had in the past involved looking into situations where the government had spent some sort of a huge amount of money in 4 or 5 or 6 years with no feedback. Every one of those turned out to be disastrous. Okay, there were no exceptions to that. I actually had a general's aide in Fort Huachuca once asked me to write up the executive summary for a project like that for the government acceptance test in 2 forms, one the way I normally would, the other in the form of a rap song, which you said was the only literary genre adequate to describe the situation. Okay, and that's what you would be looking at, if you go ahead with one of these fusion projects, which is going to take decades or billions or trillions of dollars.
Ted,
Okay, so like I said, I'm going to give this to.
have you ever read this paper that we put out? It's called The Suppression of Fusion.
No, I haven't.
I think you would like it. It goes through the history of fusion from its inception, basically, which is really, people are starting to work on it probably in the 30s, most adamantly during when we started fission, basically, which was in the 50s. And what it goes through is the fact that fusion was incredibly close to success and was actively, intentionally crushed in the late 70s, 78 to be exact. Really started in 74, especially around the whole depopulation agenda. But in 78 there was a major breakthrough at a certain point where basically all of the properties for fusion had been achieved. And at that point, the most obvious thing you would have done if you were just thinking scientifically was then to put the three together, to put the properties together, and to demonstrate that you could achieve fusion on not that you would achieve fusion. I mean, they were already producing energy from fusion, but that you could have break even. And that was not done. In fact, the opposite was done. Funding was then cut.
Okay, listen, there is one approach to fusion which I've been reading about, which sounds like it might actually be believable. This is Eric Lerner's.
Yeah, well, the thing is that
focus fusion, though he's trying to crowdsource this at this point.
Well, I'll give you a good example, okay? Focus fusion, I mean, he's just building a reactor that Bostic built. And that's a reactor that was designed in the 80s. He built one already. Bostic built one already. And that's another good example where, you have all these great experiments and they have successes and they get crushed or they get pushed into the point where, like this, for example, where Lerner's trying to get $200,000, okay? That's a drop in the bucket. That's nothing. And he's been trying to get this for how long now? And it's just a perfect example of how this plays out politically. It's not a technical question. This whole decades out is just, it's so much farce. It's just such a lie to demoralize people with. It could have happened 30 years ago at this point. But there's so many, the lies are so thick around this.
Okay, I can't believe that it wouldn't have happened by now if it was possible to do easily. The Chinese are so.
I mean, you're talking about thorium.
No, I'm talking about fusion.
No, I'm saying you were talking about thorium. It's so easy. Why hasn't it been built here?
I believe the Chinese are going ahead with thorium at this point.
We don't have.
That's what I've read.
Nuclear reactors all over the United States being built. We haven't built a nuclear reactor. We're building 2 nuclear reactors after 30 years of no nuclear reactors. That's a political decision. This is a political fight. This is not a scientific fight.
I'm sorry. Okay, that was about what I had to say. You got that.
There's a chair right behind you, Joe.
Okay.
Thank you, sir.
Hey, Leona, this is Joe.
Hi, Joel.
Getting back to helium-3,
Yeah.
I watched a program a couple of days ago on the Science Channel on the discoveries of the Cassini probe for Saturn. And at the very end, they interview Robert Zubrin, who used to be a member of the Fusion Energy Foundation. And they start talking about helium-3 on Saturn. And he actually proposes that we use Titan as
Right.
a base to send probes into the Saturn atmosphere to scoop up the helium-3. And so if anybody's worried about running out of helium-3 on the moon, we have plenty of the gas giants.
Yeah. Right.
Saturn's gravity is low enough that we can actually extract it. So this is the first time that I've heard Zubrin mention anything besides just old technology go to Mars.
Yeah.
So the other thing, thorium rockets will never get us to Saturn. Because thorium, I think the chart in your article goes through the specific impulse of uranium and thorium is similar.
Right.
That you cannot get 1G gravity acceleration with thorium rockets.
No, that's not the purpose of the thorium reactor.
Well,
This one.
we need to get fusion rockets to get to the outer planets. I just wanted to mention that.
But
Yeah. No, that's exactly right, and I think that's a right way to think. Zubrin says all sorts of funny things sometimes that aren't all that right, but that is this one I think is right, which is that we should be thinking about going into the gas giants, how to not get sucked in by the gas giants, but going to them, maybe refueling, and refueling there. I'm saying. And then the other thing I think I want to address that Ted brought up is this concept of a driver. And like you said, Zubrin has brought up a lot of things that take things that we already know, sort of off the shelf. But that doesn't really constitute a driver. Off the shelf things would be built during a driver. But a driver has to challenge everything we know. It has to push the limits. And right now, not just fusion, but really a whole control of plasmas, of the nucleus, of gamma rays, and so on, is the next step as far as our driver program goes. Yeah, thanks, Joel.
Yes. My dear friend, you and me, we know how much powerful is the power which is standing against fulfilling our dreams. You remember the government of Zulfikar Ali Bhutto or the government of Mossadegh against fulfilling the dream of nuclear energy. Now, and for a long time, we are trying, we are dreaming, but the problem is, who can fulfill this dream? And you know the point that if we have this project will make very cheap energy. Cheap energy means everything afterwards will be cheap. The food, no starvation, no poverty. Everything will be available for all humanity. This will be against the few who controlling our lives in every government in the world. Unless we get rid of this power from this beast, and we start to create a new world of friendship and harmony and cooperation between all the nations, then we can fulfill this. So scientifically, as you said, it's all set up, and we can go on and do it. First, we should put all our efforts to destruct these systems and start new humanity, new friendship for all humanity. This is my idea and my remark. Thank you.
Yeah, I think that's that's a, you know, the way that Mr. LaRouche is looking at this is how you start the friendship. Is you you show that you have a commitment to help out humanity, and people want to be your friend. Yeah, the other aspect, which I think you probably know, is that this enemy that we're dealing with, like you said, that has figured out how to stifle nuclear power, fusion, all sorts of developments that really should have already occurred in the 20th century, is very weak right now. The system is dead. I think it's at this point where we have to say, the emperor has no clothes.
I have a remark about this. You said this enemy is very weak. No,
Yeah.
this enemy is what we're living today is a fulfillment of this enemy work. It won't crisis. It won't fall of all economic systems all over the world, especially in the United States and in Europe and in Middle East. So when we have the crisis, they will come with a new system and they will come with solutions. When we are only 1 billion on earth after they make their coming war. So we will give them our liberty and our freedom. So they give us a solution. What do you think it's for? It's success for them to destroy all the systems. And our governments, Mr. Obama, if we will go to hell or we can impeach him, another government or another president will come the same like Obama or like George W. Bush. Democrats or Republicans, they working the same God, the same beast, the same devil. So unless we make how we call it, upside down, and we clear our minds and our souls and ourselves from these beasts, and we start to fulfill the still
The commitment, the project.
the commitment or the ideas of Mr. LaRouche about correcting our way economically and politically, then we have our will, the government which fulfill. We need a government and congressmen and president who love the soil of this country and the people of this country, and they are human, love also the all humanity, not serving the devil. This is the point. This is the point. They are not failing because we are separated. We are not united. They do exactly what you think is a failure. It's success. The crisis. They create crisis. They create poverty. They create difference between you and me by any means, by any names. So we should understand this and should be careful. This is my point. Tell me what's about you.
Do you do you organize? Like, do you organize your friends?
Yes, I do.
I think there's no shortcut. You know?
Yeah, we must make a revolution.
Yeah, there's no shortcut to. I mean, people aren't just going to become smarter all of a sudden.
Okay. Yeah. Okay. Yeah.
Oh,
Hey, Leona. This is
Hi.
Tom from Baytown. Oh, what a pep talk, huh? I'm with you. Screw the rules, you know. Yeah, this is what we're trying to change, you know. I mean, when we just can't stop, you know. Failure is not an option. Everybody, it's not an option. We take Obama out, and we go with Mr. Russ's 4 laws on this, and we keep pushing, we keep educating people because people are so dumbed down. You know, I mean, yeah, just literally, you know. And it's like you said, Leona, there just a second ago, something, you know, the way people that have been programmed, indoctrinated to believe, you know, to go along with the rules, you know, kind of, and what I look at, you know, it's kind of like a moral rule, you know, and like what Argentina did, telling the Grecian court, the one judge is telling a country to starve to death, not to pay their teachers, their police force, their military, anybody like that, telling him, you know, I'm not going to say it because the old ladies are here, but, you know, the change is happening. And something I learned in this program, you know, is that it doesn't happen overnight. But that's all I got to say about that, okay? It wasn't really a question, but after listening to that, I just had to say that, okay? And that's a really good presentation. One thing that I had a question on the helium-3,
Yeah.
just, I know we haven't been able to core sample the moon or anything, and I was just wondering how deep this stuff goes in the ore, you know, and now that I've learned that they microwave it and like turn the helium-3 back into a solid substance to hold it in the ore and then bring it back because helium's a gas. I thought that was very interesting. You know, I mean, until we can actually get up there and core, we don't know how deep the helium-3 goes into the surface, correct?
Yeah, I think they think it's very light. About 3 meters is probably as much as you need to mine deep. And then, yeah, you can freeze it on the lunar, on the other side during the lunar night.
Okay.
You probably had to put some more than that. Yeah, because helium is a pretty low freezing point.
That would be my life's. I'm a core driller too, by the way. That would just be great. Yeah.
Hi, Leona. Joe.
Hi.
You know, I think I just keep thinking back to this inspiring speech that Modi, you know, who is a new leader on the world scene, made at the BRICS, right? Because, you know, he just talked about how this is a unique institution that has a credit policy that is guided by the future, right? You know, and of course that BRICS is so profound because it also brings together not just the majority of the population, but also all the ethnic and religious and, you know, racial and all the different, you know, representative divisions that the oligarchy always pits against each other. But if you have an organizing principle oriented toward the future, you know, this is where we're going to take things, you know, this is what we want the future to look like, right? And then we're going to organize. And, you know, right after that, he kicked out John Kerry and the WTO and said, right, just like Kirchner standing up to the vulture funds, right? It gives them a certain strength because they're saying this is where we're going to take our future, you know, and organize things accordingly. And so, of course, we don't know all the technical problems to overcome on fusion any more than we did on getting to the moon when Kennedy came to Houston to say we're going to go there, right? But we designate that this is the future that we have to accomplish, right? Then, you know, that's the primary thing, right? And I'm thinking of you know, the Schiller poem Columbus, right? Ever run west. What lies beneath thy ken, you know, and this is what we must fulfill, right? That's the inspiration there, and of course LaRouche makes it very specific in terms of credit policy oriented toward the future to galvanize all these other allies that we're working with. And also, could you say something about hydrogen bombs? You know, that is the other form of fusion that's out there. You know, there is, if we don't get the peaceful kind of fusion, there is thermonuclear fusion abundantly available on the Earth in hydrogen bombs. Is that a deuterium pellet in the middle there that they're igniting? How does that work?
I think it's, yeah. Well, for just the first part of your comments, the other thing I would keep in mind is also that, yes, this is our future, but the way that nature goes is when we don't go to what is naturally our future, we cease to be plentiful in a euphemistic way. But basically, we run into problems, and now we see them now. You know, the water crisis because we didn't build a water system. We didn't figure out how to control the water system. So therefore, we have a water crisis now. Totally foreseeable, was foreseen, was planned for, and so on. But just didn't happen, and so on. So that's the other aspect of it. There's a natural progress there's a natural process of progression, and it's not just something that's good to do. When you don't do it, you won't survive. And so that's why I called my new paper just basic economics. It's not you know, out there visionary thing. It's just really basic economics. As far as the hydrogen bomb goes, there was a project. It was called PACER, and I think there's a version called HACER, which Ralph Moyer designed. And I think Joel knows something about it. But they did have a project to put a big hole in the ground, I think a mile down, and just throw nuclear bombs down into it at specific frequencies. I forget what the frequency is. And have basically some form of fluid that would capture all the neutrons and, you know, turn it into steam and so on. Turn it into electricity, basically. So that was, of course, the first thing. Was one of those, well, we already got it. We could do it now. You know, I think there were some... I didn't look into exactly what the technicalities were, whether it's still considerable or not. I think they just used DT.
It caused earthquakes.
Yeah.
Oh, it caused earthquakes. That is one of the big things, yeah.
Yeah.
It caused earthquakes, which people don't really like. But of course, the other thing it's really great about fusion is that because we've had to do all these different methods, is that all the different methods, and if you go look at them, I'm going to try to have I tried to put out a list of all the different reactors with this article. I just didn't make it in time. But with all the different ways that people have tried to create fusion. And, you know, fusion is a very simple process in a sense. It's just fusing atoms. But how you do it can be totally different, whether you shoot 192 lasers at it, or whether you put it in a big plasma chamber, or whether you wind it up in a filament of dense plasma, or whether you accelerate it with a huge electric field, or whatever. There's all different ways. And each time they tried a different way, they discover completely new properties about physics, like basic physics. So I think that's actually more important than the getting the fusion part. And fusion becomes sort of a tool to get there.
Hey, Leon, I just wanted to make sure that people know. Some people in the room, a few of us were able to read most of your paper before the presentation today, but for those who have not had a chance to read it for further elaboration on what Leon has gone through, she wrote a paper called Fusion Basic Economics, and that can be found on the 21st Century Science and Technology website. So I guess, what is that, 21stcentury.com?
21st Science.
It was also on the LPAC.
It's on the LPAC site too?
Yeah.
Okay.
There's a whole section on fusion and design of policy.
Okay.
I think that's there's a whole series of papers listed there.
You can find this on the website, LaRouche Pack, at Fusion and the Science Policy. I might have messed that up, and if I did, Leona, tell them. But I think that's right.
You can find it on the front page.
Yeah, find it on the front page there. Okay, so people should take a look at that. I just wanted to reiterate something that you said, Leona, because I think especially the destruction that has been done to our society, and particularly after the death of President John F. Kennedy, has conditioned our population to not think into the future and to always, with the free market, the Wall Street society, the get rich quick, quick orgy society that we have in our population, thinking about something like this from the standpoint of when Kennedy did his Apollo mission, the moon mission, in space, wasn't just getting to the moon, it was a total science driver with the Apollo mission. That wasn't just going to be like some day trip, get to the moon, a couple of scientists do a couple of experiments and do it. But it was going to actually transform everything that is essential to our needs in terms of, our capabilities to be able to succeed or to live here on this planet. Everything we thought about from our technologies, our food production, everything was being driven by this process. And so, when you think about the Apollo mission, you also had the driver in your education system. People, at the time of the Apollo mission, they might not have been in the science field or something like that, but everybody from grade school on up was being affected by it. And right now, we don't have that sense of direction any longer. And when we're thinking about these types of projects, because as you said before, people have just been so beaten down and so demoralized. It can't happen, the money's not there, this is not there, that is not there. But instead of thinking about what is the necessity of it for the increase in the productive powers of mankind for us to be able to solve all of these problems that confront us on the planet. So I'll say this, yeah, the thorium does exist in abundance on the planet. But at the same time, and it can do all of these things that you're saying, Ted, but it doesn't give us the type of driver that is absolutely essential in destroying this idea that, we have limited capabilities.
Yeah, I'm not saying that you shouldn't do fusion. I'm saying fusion should be on the back burner. We need the electrical generation capability. It's like we need the power.
Mm-hmm.
And thorium, like I said, does not require anything new being invented. You just start building.
But we need to start building nuclear plants right now. So we should go to more advanced designs that exist right now as a transition. That's obvious.
Thorium right now is the most advanced thing you could build. It would be a huge improvement over any previous reactors.
Yeah, but
absolutely huge, totally safe.
So the point is, we cannot have anything hold us back in terms of this commitment to a science driver for human progress. And I think that that's the challenge that confronts us right now. And the Apollo mission was, in that being destroyed, that direction is, what we've done to our culture as a result of that is a real example of what the fight that we're really up against right now.
Yeah. That's a good point, Keisha. I think also it is this sort of settling for something just a little bit better. And you talk to any congressman today, and there are very I've asked people, where do you think we should be going? And a very common answer, unfortunately, is it should be better than this. What does that mean? What does better than this mean? But then the other thing is, I thought about, Ben and I were discussing this this concept of the coal versus helium-3, and you know, then just thinking about, because there's all these people who are so worried that they're going to lose their jobs if we get rid of fracking, for example, or something like that. And I don't think people realize that. I mean, the way that Obama's going about it, just shutting down coal, yes, you're gonna lose your job. But people don't realize that mining helium-3 takes a lot. It takes a whole advanced society. It takes rocket engineers. It takes people who are building all sorts of more precise nuts and bolts and so on. And we're going to soon find out that the number of skilled workers we have is so the number of people that actually are capable of working are probably not sufficient right now. In other words, we do need more people. But then we'll also find that we need a serious work, sort of like a WPA, a transition program, to take the current workforce and upshift the entire current workforce, besides the obvious, educating the upcoming workforce.
It is rocket science.
Joe.
It is rocket science. Yeah. I was gonna, it's funny you brought that up, like where we should be going, and I know that when I was organizing in DC, a lot of interns would tell me we should be going down to the poorhouse or some other pub down the street. That's their idea of a direction for society. But I had two questions, and you kind of started to get into that.
That's where they're taking us too. Sorry.
What's that?
Keep going.
Yeah. So the first question is off. If you could begin to describe some of the ways that the science driver of fusion would ripple through society. Because I know it's not just about, okay, now we have a lot of cheap electricity, and now we can build rockets to stop comets from hitting Earth in time. And those are all very real things, and those on their own will have ripple effects through the society. But, I mean, for example, one of the things that I thought was really interesting from a fusion economy article or something like that from a couple of years ago, talking about how it might affect the isotopic content of our food, make our food more nutritious. So I don't know if you have if you've looked into what some of the spin-off applications and things that would go on would be. The other question I had, I'm not really exactly sure how to formulate it right, but I was thinking about Kepler, Johannes Kepler, and you had mentioned something about tuning the plasma, and it makes sense that there would be a harmonic technology that's involved, and I was wondering if there's any way to look into some of these things about if it follows up with actual, do you tune it so that it's harmonic? Do you tune it so that it's out of tune? Or like, do you know anything about that? Because that was it was provocative, so I wanted to learn more.
Okay, I'm going to address the second one first, because the first one I actually went through a lot in the article, but I can go through some of that too. So, tuning the plasma idea is very, very cool. What they have found from working with plasma is that none of the statistical mechanics that we've tried to apply, whether to fluid or to gases, works. And the coolest thing about plasma is that technically you don't need any quantum mechanics to deal with it. It's not superposition. It's not really dealing with anything that small. It's just electromagnetic fields. And yet, and mass. And yet, just putting that together does not give you a model that works. And so technically all the so-called forces are there, but nothing that but so many things that the plasma is doing does not fit in that, is not predictable. So after it happens, and you can say, okay, according to how these fields would work, then you could describe it. But they don't predict it. And one of the things that they don't predict is that plasmas like to be in certain configurations. Mm-hmm. And you try to make plasma become more dense and hold more energy in, and so on, and use magnets and so on to try to get it to do that. But they found that the plasma likes to do that anyway, if you know how it likes to do that. One good example is the tokamak. So the tokamak they found in the 80s. It's into this state that they call the H mode. And for Keisha and whoever went to that lecture on plasma physics, that guy, he's working on this particular thing, which is the H mode. Now the H mode is this mode that the plasma gets into. So that what they do is they heat it up, they continually heat it up, and usually what happens is the more heat you put in, the more wild the plasma gets and the more unstable it gets. So they'll heat it up, and it's getting sort of turbulent. It gets really turbulent, and it gets more and more turbulent. And at a certain point, it just stops, and it becomes really quiet. And suddenly, the confinement gets better by 2 times, and the density gets higher. The energy stops leaking out as much, and so on. It gets into this state that is incredibly stable. Now, stable is in the, it's less than microseconds for them, but it's much more stable than they had previously. And in the 80s, they didn't know what was going on. They started a whole project actually in Texas that was supposed to replicate this, and they couldn't, and that was a failure. But then ever since then, they have figured out how to replicate that process. Now, they didn't know why it was occurring. They still don't really know, which is why there's a whole group investigating just that. How is this occurring? But every reactor, every tokamak works on this. ITER is going to work in H mode. And so it's sort of, okay, it's sort of accepting the fact that this occurs. There are other reactors that explicitly take advantage of the fact that plasmas like to do these odd things, like to concentrate and twist and create these increasing singularities. And that's what this learner thing was that somebody mentioned. This reactor that Eric Lerner is built is based on. And there are several other reactors that are based in some way on that idea. But what it shows us is that whether it's, I don't know if it's tuned to anything musical, but it's definitely tuned. It's harmonic in some way. There's something where it's a discontinuous least action. Right? There's not a continuity of states. It's not homogeneous. And it is, I put in a short footnote, but I wanted to actually put in a whole box about this, which is, when I mentioned this to Dennis, he compared it to tuning a piano. Most people know, or people who have played a string instrument know that when you're tuning the instrument, tuning 2 strings, as one string comes more into harmony with the other, it starts to get this that sound. It's called beats. So it starts to get more turbulent until the point where you actually are in harmony with each other, and then they're just in harmony with each other. And he said that even when you get into tune on a piano, there's still fine tuning within the note, which then gives you the color. Sort of gives you the whether it's a tinny color or it's just too resonant and so on. Which I thought was interesting because then you get it. It reminded me of these levels of tuning. For example, in chemical processes or with nuclear processes or subnuclear processes. Yeah, I think that's one of the biggest advantages is that ever since we started working with plasma, this is the case. It's one of the places. It's actually the whole domain of high energy density physics, which it's just a whole new domain, and it shows, you know, it does show that the universe is much more organized and harmonic and higher density than our current physics accounts for. Oh, and then, okay, sorry. Well, that sort of actually addresses your first question too, because that itself, I think, is going to transform. That's going to transform all the sciences. Right now, all the sciences have some aspect of this. I don't know how to explain it. It's homogeneity, and I guess a good example is biology. You mentioned the isotopic content of food. Biology is largely treated as an abiotic process, which is kind of, I guess it's a little ironic, right? But biology, a lot of, especially molecular biology, deals with molecules, deals with dead things, basically, and deals with trying to explain living things with dead things, and therefore not finding that you can explain life with dead things. But as Vernadsky opened up, Vernadsky opened up this whole field that we should reshape physics, we should reshape our understanding of how the universe works, how the so-called dead solar system works, through our investigation of life. Because obviously the solar system, our universe, allows life to exist, so it must be a natural part of everything. So therefore, our study of life should inform us of what are actually universal principles. And this is the thing, is that he brought up, and other people have brought up since then, that according to the way life works, things are not entropic. Things don't go towards disorder. They go towards more order. And they're not, and like life, for example, where, you know, most life systems are very delicate. Can't get too hot, can't get too cold, can't have too much magnesium or too little, and so on. It's very, very delicate. And in that sense, you know, these plasmas are very similar. They act as a whole, first of all, as a unit in such a way that one part of it acts on another. But they have these non-entropic tendencies, which have a closer characteristic to the way life works than what is considered non-life. We may find out, since plasmas are 95% of the universe, that that's more universal than what we think is true today.
99 point something. More than 95%. It's more like 99.9 something.
Yeah, I've heard various. That's why I wrote 95 to 99, because I've heard various estimations. But yeah, I think you're right. It's probably 90. I mean, considering that most of the mass is in stars and nebula, which are all plasmas, that I think you're probably right.
Right. I'm gonna cut it off.
Oh, just one more thing is that, as far as an example, at least, I mean, of how these things will propagate, like you said, it's not going to be just energy, and you can produce energy by just building a lot of nuclear plants. That's true. It's not just energy. It is the full control over what the sun used to do for us exclusively, and the full control over the atom, over gamma rays, and so on. And being able to use elemental properties which we've never even touched. And the example that I used in the paper was of diamond, where they made pure isotopic diamond, and they found that it's much higher, much harder, better conductivity, much better thermal conductivity. In other words, if you wanted to build a drill bit out of it, it would be way better. Mm-hmm. And even more interesting then is, similar to the way nanotechnology is introducing completely new properties of materials that we just didn't even know about, much less control. You should expect something like that with a finer control of isotopic composition and of elements that are on the periodic table but don't actually exist in nature.
Yeah. Can I possibly say a little bit about plasma in space?
Yeah, sure.
Okay, this little book of Troy McLaughlin's and mine talks about the origin of our solar system as well as human origins. And space itself used to be thought of as a vacuum. We know better than that now. It's like 99.9% in plasma form. There's a problem with the things that they teach in schools about galaxies and the way galaxies are held together and the formation of solar systems. They teach a gravity-only cosmology. Okay, now, the idea of holding a galaxy together with gravity is ridiculous. It's like asking the littlest kid in the school to do the powerlifting event. Gravity is by 40 orders of magnitude the weakest force in nature. They end up having to invent things to try to make that system work. Dark matter, dark energy. And these are things which nobody's ever seen, and the numbers don't add up, right? They're claiming that dark matter is like 95% of the universe. I mean, that doesn't work. I mean, that's still not going to hold a galaxy together, the reasons for that. What you actually get in space is this plasma, and you get charge separation over gigantic regions of space. And because of the charge separation, you get electrical currents flowing through space, and these are called Birkeland currents. And more often than not, they take the form of twisted pairs of current, which look like DNA, RNA strings. And these twisted pairs of currents have electromagnetic pinch points, which they call Z-pinch or Z-pinch points. And these Z-pinch points of these Birkeland currents have more than enough power to agglomerate plasma into solid objects. At the largest possible scale, these things represent strings of galaxies. Now, there's no conceivable way that gravity could form a string of galaxies, and these strings of galaxies actually retain the helical form of the Birkeland currents which create them. Now, on a smaller scale, these things which I just described are called Herbig-Haro objects, and these are proto-solar systems. They don't last for a very huge amount of time, thousands of years, tens of thousands of years, but not millions or billions. Okay, that these systems evolve into rotational systems like our own solar system, right? But solar systems originate not in the form of rotational systems, but in things which look like a string of pearls, like a necklace which is being held taut. Now, sometime in the recent past, 50, 60, 100,000 years ago, our own solar system was still in this sort of form. Our solar system was in two parts. There was a northern and a southern part. If you wanted to believe that a solar system actually formed up from a swirling mass of solar material the way that they teach in school, then you would expect the spin axes of the planets to be roughly perpendicular to the plane of the system. The Sun and Jupiter and Mercury do look like that. The axis tilts of those bodies are less than 10 degrees. You've got two bodies, you would expect all of them to look like that, but they don't. You've got two bodies which are oddball cases, which have their own separate little stories. Venus is upside down. It's like 180 degrees off. It rotates retrograde to the system. Uranus is laid over on one side, like about 97 degrees. Okay, the other four bodies, Neptune, Saturn, Mars, and Earth, all have the same roughly 26-degree axis tilt. What that tells you is that they were captured at some recent point in time as a group. Now, if you can picture these things still being in the form of a separate Herbig-Haro string, one of these necklace strings that I just described 50 or 60,000 years ago, then basically what happened is that the string of bodies flew into the plane of the Sun system from the south at a 26-degree angle, and as the individual bodies peeled out and began to orbit the way they do now, they simply kept the 26-degree angle, actually 24 to 28, right? But visually, they all look pretty much the same. I mean, the center of that is, I'm sorry.
No, this is very good. It is interesting, but I think we're gonna have to let you come in and do a class for us on it.
Right. No, I'm just saying that this whole thing of plasma and space is more interesting than what you might have read.
Yeah.
Good.
No, that's very good.
Just showing why we have to learn more about plasma.
Right. Right.
Yeah.
So he's wondering
I'm sorry, that's a little bit weirder than what you normally read about cosmology.
No, cosmology is weird.
Yeah, it's very weird.
Hey, I'm going to have to hop off in a little bit here because we've got another class that's scheduled for this spot here.
Okay.
7. But I just want to say that I think any theory right now, considering what I just said about how much we're challenged by the high energy density physics, which is what all the stuff that I mentioned right now, lasers, plasmas, they all fall in that domain, high energy density. Just considering how much of a challenge it is, I think any theory right now that claims that they can explain it with current physics, whether it's gravity, electromagnetics, or anything, I think is going to be wrong. And I think we have to take this idea that there may be physics out there, or there may be things that we just have not at all considered.
Mm-hmm. That's good.
That's why we have to go out there.
Yeah, exactly.
Thanks, Leona.
Thank
you.
Until next time.
Feel free to email questions if you like.
Okay.